in part 2 of your properties of radicals, we did square roots in the first part, and now we're going to do cube roots. So remember, square roots, let's say if I had an exponent of 2, or I had an exponent of 4, or I had an exponent of 6, all of those multiples of 2, right, make a perfect square root because there's a 2 out here. So that means that perfect cubes, the exponents for perfect cubes would be like to the 3rd, to the 6th, to the 9th, all multiples of 3. So you're going to do the same thing. Now remember, you can take the cube root of a negative, and when you do, it comes out to be negative. So this is really the same thing as a negative cube root of 128. So let's just remove the negative, put it out front, that way we don't forget our negative in the end. So we're going to do a factor tree just like we did for your square roots. So 128, that will divide by 2 because it's even. So 2 and 64. 2 is a prime number. And then we have 64, that's 2 times 32, and 2 is a prime number. And then 32, that would be 2 times 16. 2 is a prime number. 16 is 2 times 8. 2 is a prime number. 8 is 2 times 4. 2 is a prime number. And 4 is 2 times 2. So we've got 1, 2, 3, 4, 5, 6, 7 2's. Now since I'm doing cube roots, I would say to myself, does 7 divide by 3? The answer to that is no. So I need to split up my 7. So I'm going to think, what's the biggest number that's smaller than 7 that will divide by 3? That would be 6. So I'm going to use 6 of my 2's to make my perfect cube. And then how many 2's does that leave left over? Just 1. And remember, you always want that exponent to be smaller than your root, the one that's going to be left under the root. So you have your negative out front, and then we're splitting this into 2 separate cubes. Make sure that your little cube root is in the little crook of your root symbol. So we have 2 to the 6th, and then we also have the cubed root of just a 2, right? This is the one that's going to stay underneath because I can't simplify it anymore. So I'm going to take my base of 2. I'm going to divide the 6 and the 3. 6 divided by 3 is 2. And then I've got my cube root of 2 at the back here. So just square that. 2 squared is 4. So we get negative 4 cube roots of 2. All right, number 2, I notice that's a positive number underneath, so I don't need to worry about the negative on the outside. So we'll just go ahead and do a factor tree for 54. So 54, that would be 2 times 27. 27 is 3 times 9. 3 is prime, and 9 is 3 times 3. So we have 3 of the 3's, and then we have a 2 to the first, right? So is 3 to the 3rd a perfect cube root? Yes, because 3 will divide by 3. But can I do anything with this 2 here? No, because it already has a power of 1, right? And that's smaller than 3. So I've got the cubed root of 3 to the 3rd, and then the cubed root of 2. What is the cubed root of 3 to the 3rd? It's 3, because 3 divided by 3 gives me a power of 1, but I don't need to write that, right? And then you have your reduced cube root at the back. And then you're done with that one. So on number 3, have a positive number under there, so we're going to go ahead and do our factor tree for 135. 135 ends in 5, so I know that it divides by 5, right? So we've got 5 and 27. 5 is prime. 27 is 3 times 9, and 3 is prime. And 9 is 3 times 3. Both are prime. So I have 3 of the 3's, and then I have a 5 to the first. So 3 to the third. Will that 3 divide by 3? Yes. And then can I do anything with this 5 to the first? No, because 1 is already smaller than 3. So I have the cubed root of 3 to the third. And I still can't stress enough that you put your 3 inside the little hook. Okay. If you don't put it there, then I might think it might. If you end up having stuff out front, like if I did, like let's say I wrote like A, and then I had a cube root, and I did like this, I'm going to be confused, and I'm going to wonder if that 3 is supposed to be here or the 3 is supposed to be here. Okay, that's why it's important to write it properly. Okay, and then we have the cubed root of the 5. So the cubed root of 3 cubed is 3, and then we have the cubed root of 5. So on number 4, when you look at that one, you have a negative underneath, and so I know my answer is going to be negative, so I'm going to take it out so I don't forget that I have it there, and I'll just keep bringing it all the way down. So 108. 108, that would be 2 times 54. And 54 is 2 times 27. And 27 is 3 times 9. And 9 is 3 times 3. So I have 3 of the 3's. We like it when we get a 3 up there, right? And then I have 2 of the 2's. So on this one, we know that that 3 is going to divide by our root of 3, right? So that's a perfect cube. Is there anything I can do with 2 to the second? No, because 2 is already smaller than 3, right? So I've got the cubed root of 3 to the third. Always put your perfect cube in the front. And then I can't do anything with 2 to the second power, so I'm going to go ahead and say 2 squared is 4. All right? And then I've got my negative. What's the cube root of 3 cubed? 3. And then I have times the cubed root of 4. So now that we've got that down, let's focus on putting in a variable. So you do the same thing that you did with square roots. You're going to separate it and do your number, and then do your variable. So 125. By the way, it's always good to check and see if those are perfect cubes. Is there a number times itself 3 times that makes 125? That's 5, right? And there's a way for you to do that in your calculator too. So you can check to see if these are a perfect square root in the calculator. So if you look right here above the caret, there is a little X with a root, okay? And so that's in green, so I know I have to press my green second button. But first you want to put in your root number. So like if I put in 3, and then I press the second and the caret, it changes that 3 to a little 3. And if I put in 125, then I got 5, right? If it's not a perfect cube, you'll get a decimal. So you can at least check to make sure that they are perfect cubes before you start. Okay, so I already know that that's going to be a perfect cube. I'm going to leave it alone for a second. But will this 7 divide by 3? No, so I'm going to have to split it. And remember, I don't take anything out of the roots. I don't actually root anything until I have everything all split up. So what is the biggest number that's smaller than 7 that will divide by 3? That's 6, and that would leave 1x left over. So now that I have that split up, I'm going to do my perfect cubes first. So this we already decided was a perfect cube, so we don't need a factor tree. And this is a perfect cube as well. So the cubed root of 125 we figured out was 5. And then we have the cubed root of x to the 6th. So I'm just going to take that 6 and I'm going to divide it by 3, which gives me 2. And then here's the leftover that I can't simplify any further. And remember, this exponent should always be smaller than your root number if you've left it underneath the root. So we're going to focus on the cubed root of 8 and the cubed root of x to the 4th. So 8, that's a perfect cube, right? 2 times 2 times 2 is equal to 8. But is 4, an exponent of 4, a perfect cube? No. So I'm going to have to split that one. So I'm going to go ahead and leave my 8 alone for a minute. That way I can do them all at the same time. I just think that's easier. So what is the biggest number that's smaller than the 4 that will divide by 3? That would be a 3. And that leaves how many of your x's left? Just 1. So out of these 3, your perfect cubes would be the 8 and the x to the 3rd. So I'm going to do those first. The cubed root of 8 is 2. And the cubed root of x cubed is x. Remember, 3 divided by 3 is 1, but we don't write that, times the cubed root of x. All right, on 7, they already put the negative on the outside, so that's kind of nice. So we'll leave it out there. And then we have the cubed root of 343 and the cubed root of n to the 2nd. So 343, if we check that to see if it's a perfect cube, we get 7, right? So this is a perfect cube. What about this one? Should I split this up? No, because this 2 is already smaller than 3. There's nothing I can do with this. So I keep the negative. The cubed root of 343 is 7. And then there's nothing I could do with this because that power is smaller than 3. So it literally just stays there. There's nothing more I can do with it. All right, so on this one, I already know I'm going to have a negative on the outside, right? And then I need to do the cubed root of my 64 and the cubed root of the x to the 5th. So 64, is that a perfect cube? Okay, so I know that's going to be a perfect cube right there. That's going to be 4. What about x to the 5th? Is that a perfect cube? No. So I know I'm going to have to split that. So I'm going to leave my 64 by itself. I'm not going to actually reduce that yet. And I'm going to go ahead and split this one up. So I have a 5. What is the biggest number smaller than 5 that will divide by 3? That would be 3, right? And how many x's does that leave left? 2. And remember, this one that you have left over should always be less than your root number. So your perfect cubes are the first one and the x to the 3rd, so you're going to do those first. Keep your negative out front. The cubed root of 64 is 4. And then you have the cubed root of x to the 3rd is x. And then your cubed root of x to the 2nd. All right, so let's do the cubed root of 16 and the cubed root of p to the 9th. Is 16 a perfect cube? No. So we're going to have to do a factor tree for 16. So 16 is 2 times 8. 2 is prime. 8 is 2 times 4. 2 is prime. And 4 is 2 times 2, both of which are prime. So we have 2 to the 4th. Now, is that 4 going to divide by 3? No. So what is the biggest number smaller than 4 that will divide by 3? That would be 3, right? And how many 2's does that leave left over? Just 1, right? So I've got the cubed root of 2 to the third, and the cubed root of 2. Now, let's check our variable. Will this 9 divide by 3? Yes, so I don't need to split that up because that's a perfect cube. So when you look at your 3 here, the first one's a perfect cube, and the p to the 9th is a perfect cube. So I'm going to do those two first. The cubed root of 2 cubed is 2, and the cubed root of p to the 9th is p to the third, because 9 divided by 3 gives me 3. And then you have your cubed root of 2 at the back. Okay, so I know I'm going to have a negative as an answer. So I'm going to focus on doing my number and doing my variable. So 256, is that a perfect cube? No. And remember, you can check that if you get a decimal in your calculator. It's not a perfect cube. So we're going to do a factor tree for the 256. So 256, that will divide by 2. That gives you 2 and 128. 128 will also divide by 2. So that gives us 2 and 64. And 64 will divide by 2. That's 2 and 32. 2 is prime. 32 is 2 times 16. 2 is prime. 16 is 2 times 8. 2 is prime. 8 is 2 times 4. 2 is prime. And 4 is 2 times 2. So we have all these 2's. 1, 2, 3, 4, 5, 6, 7, 8 2's. Is that 8 going to divide by 3? No. So we have to split this up. So what's the biggest number that's smaller than 8 that will divide by 3? 2 to the 6th, right? And then how many does that leave left over? 2 of them, right? And that exponent is smaller than 3. So I know I did a good job on the first one. So keep your negative out there. So you have 2 to the 6th, and then you have 2 to the 2nd. Now, do we need to write 2 to the 2nd, or can we go ahead and just write 4, right? So let's do that. Okay? Then we know that this 8 is not going to divide by 3, so I'm going to have to split up my variable. So what's the biggest number smaller than 8 that will divide by 3? 6. We just did that, right? And that leaves how many left over? 2 of them. Always make sure that that leftover part has a smaller exponent than your root number. So I've got, this would be 2 to the, this is your perfect, right? And this is your perfect. Always do those first. 6 divided by 3 would be 2, correct? And then, same thing here. Take your x. 6 divided by 3 is 2. And then underneath your cube root, you still have a 4 and an x squared. You're just going to multiply those together underneath. And then you need to finish off your front here. 2 squared is 4. So I get negative 4x squared times the cubed root of 4x squared. So remember, focus on each little part individually, and then you can put them back together.